Hello students, welcome to our student support program for mathematics grades 10 and 11. Our topic for today is indices. This is the last part on the chapter indices. So let us start. In the previous lessons, we have learned about how to write a number in index form and in expanded form. We have also learned about the multiplication law of indices, the division law of indices, the power law, the zero index, the two important rules, the negative law of indices, and fractional indices. In today's lesson, we will learn about how to solve equations involving indices. So let us start. What are equations involving indices? The unknowns are either the index or the base. Here are some examples of equations involving indices. So you can see in part A, the unknown is the index, whereas in part C, the unknown is the base. So how are we going to solve such type of equations? Let us take a few examples. Case 1, if a power x is equal to a power y, we can see here that we have the same base. So if we have the same base, we then equate the powers. That is, x will be equal to y. So let us take example 1. Solve the following equations. We now have a look at the solution. Part A, 3 to the power of x equal to 3 to the power of 4. So here, since the bases are the same, we equate the powers and we get x equal to 4. Part B, 5 to the power of 2x equal to 5 to the power of 6. So here again we have the same base, so we can equate the powers. 2x equal to 6 and x will be equal to 6 over 2, which is 3. Part C, 2 to the power of x plus 1 equal to 2 to the power of 7. Again, we have the same base, so we equate the powers. X plus 1 equal to 7 and x will be equal to 7 minus 1, which is 6. Part D, 6 to the power of 3x minus 1 equal to 6 to the power of 8. The bases are the same, so we equate the powers. 3x minus 1 equal to 8, 3x will be equal to 9, and x will be equal to 3. Now example 2. Solve the following equations. Part A, 6 to the power of x equal to 36. So what do you notice here? The two bases are not the same. Why? Because 36 has not been written in index form. So now I write 36 as 6 to the power of 2. So here the bases are the same. Equating the powers, we get x equal to 2. Part B, 2 to the power of 2x equal to 64. So here also I have to rewrite 64 in index form, which is equal to 2 to the power of 6. So I get 2 to the power of 2x equal to 2 to the power of 6. We can see that we have the same base, so 2x equal to 6 and x equal to 3. Part C now. 5 to the power of x plus 1 equal to 125. The bases are not the same. I rewrite 125 as 5 to the power of 3. Now we have the same base. We equate and we get x plus 1 equal to 3. So x will be equal to 2. Now we look at case 2. If I have a power x equal to b power x. So here the powers are the same, but the base are not. So what we have to do, we equate here the powers. Since we have the same powers, we equate the base and we get a equal to b. Example 3. Solve the following equations. So I repeat, here we have the same powers. So we are going to equate the bases. Part A, m square equal to 3 power 2. Equating the bases, we get m equal to 3. Part B, f cube equal to 5 to the power of 3. So comparing the indices and the bases, we get f equal to 5. Part C. Here we can see that neither the base nor the index are the same. So what I'm going to do here is convert the 81 to base 3 so that I get the same powers and then I can compare. So 81 will be written as 3 to the power of 4. Now I can equate t equal to 3. Part D, d power 5 equal to 32. So how can you rewrite 32? 32 can be written as 2 to the power of 5. So comparing the bases and the indices, we get d equal to 2. Now example 4, we are going to solve the equations, but we will also have to apply the different laws of indices. So let us have a look at the solution for part A. 2 to the power of 1 times 2 to the power of x equal to 2 to the power of 5. Remember, the 2 is 2 to the power of 1. So applying the multiplication law of indices, I get 2 to the power of x plus 1 equal to 2 to the power of 5. Here the bases are the same, so we compare the powers. X plus 1 equal to 5. X equal to 4. Part B. 5 to the power of 3x times 5 to the square is equal to 125. So I can write 125 as 5 to the power of 3, and I can also use the multiplication law of indices on the left hand part. So I get 5 to the power of 3x plus 2 equal to 5 to the power of 3. Since we have the same base, we can compare the powers. 3x plus 2 equal to 3, 3x is equal to 1, and x equal to 1/3. Part C. 3 to the power of 2 over 3 to the power of y equal to 81. So I can write 81 as 3 to the power of 4. And I can use the division law of indices to get 3 to the power of 2 minus y. So comparing the powers, we get 2 minus y equal to 4. Minus y will be equal to 2. And y will be equal to negative 2. The next part now, 6 to the power of 2x equal to 216. So I can rewrite 216 as 6 to the power of 3. 6 to the power of 2x equal to 6 power 3. Equating the powers, 2x equal to 3, x equal to 3 over 2. The next part, 4 to the power of 3x minus 1 equal to 32. So 32 can be written as 2 to the power of 5. Therefore, I have to rewrite the 4 as 2 to the power of 2 so that I get the same base. Applying the power law and comparing, I will get 2 into 3x minus 1 equal to 5. 6x minus 2 equal to 5 by expanding the brackets. 6x equal to 7 and x equal to 7 over 6. So now you have a few questions to practice on solving equations involving indices. In today's lesson, we have learned how to solve equations involving indices. Since it is the last lesson on indices, I have also included a few past examination questions for you to practice. These questions will be on the whole chapter of indices. So students, we have come to the end of this lesson on indices. I hope you have understood the concept of indices and will now be able to solve questions on this chapter. Until we meet again, it's goodbye.